Rust is not damage. That sentence is going to change how you look at every rusted tool, every corroded bolt, every orange-stained piece of metal you have ever thrown away thinking it was destroyed. Rust is not damage. Rust is a disguise. It is a thin chemical mask sitting on top of perfectly good steel. And beneath that mask, the original metal is exactly the same alloy it was the day it left the foundry. What you have been calling destroyed is actually hidden. And what the rust removal industry has been charging you $15 to $40 per bottle to dissolve, using products filled with hydrochloric acid and phosphoric acid that eat your skin, corrode your lungs, and attack the good metal along with the rust, can be dissolved by a powder that is found naturally in every lemon, every orange, and every grapefruit on Earth. The powder is citric acid. It costs $1 per treatment. It is food grade, non-toxic, biodegradable, and safe enough that it is the sour ingredient in the candy your children eat. And it removes rust through a mechanism so elegant, so precise, and so selective that it dissolves the iron oxide and leaves the underlying steel completely untouched. Not approximately untouched, chemically untouched. The citric acid molecule physically cannot break the iron-to-iron bonds in solid steel. It can only break the iron-to-oxygen bonds in rust. It is a chemical scalpel that removes the disease and leaves the patient whole. And the rust removal products industry, which generates billions in annual revenue selling you acids that destroy your metal while pretending to save it, has never once put this $1 powder on the label of a mainstream product. Welcome to Camping Secrets. If these stories matter to you, the subscribe button and the bell are the best way to make sure this knowledge survives. This is where we dig up what the industry buried. Now let me take you inside the rust itself, because until you understand what rust actually is at the atomic level, you will keep believing the lie that it means the metal is gone. Iron is element 26 on the periodic table. It is the fourth most abundant element in the Earth's crust. When iron is refined into steel and exposed to moisture and oxygen, the surface atoms of the metal undergo a chemical reaction called oxidation. Each iron atom on the surface donates electrons to nearby oxygen atoms. The iron becomes a positively charged ion. The oxygen becomes a negatively charged ion. They bond together and form a new compound, iron oxide, which is the orange-brown flaky material you call rust. The chemical formula for the most common form of rust is Fe2O3, ferric oxide, 2 atoms of iron bonded to 3 atoms of oxygen. The critical detail is this: the iron atoms in the rust are still iron. They have not been converted into another element. They have not disappeared. They have not been consumed. They have been bonded to oxygen atoms in a compound that happens to be orange, flaky, and structurally weak, but the iron is still there. This is why rust is a disguise, not a death sentence. The iron atoms on the surface of your tool were kidnapped by oxygen. They are being held captive in a compound that looks terrible and has no structural strength, but they are not gone. And more importantly, the steel beneath the rust layer, the iron atoms that were not exposed to moisture and oxygen, are completely unaffected. They are the same metal they always were. The rust sits on top of them like a coat of paint, an ugly, flaky orange coat of paint that can be removed. The question is how you remove it, and this is where the rust removal industry has been lying to you for over a century. The conventional rust removers sold at every hardware store fall into 2 categories. The first is strong mineral acids, hydrochloric acid, sulfuric acid, and phosphoric acid. These acids dissolve rust aggressively. They also dissolve steel. They do not distinguish between the iron in the rust and the iron in the good metal beneath it. When you soak a tool in hydrochloric acid, yes, the rust comes off, but the acid also attacks the underlying steel, etching pits into the surface, thinning the cross-section, and weakening the metal. You remove the disease by poisoning the patient. The tool looks cleaner but is structurally compromised. The second category is phosphoric acid converters, sold as navel jelly or rust converter products. These convert the iron oxide into iron phosphate, a stable black coating that seals the surface. This is useful for painting over rusted metal because it creates a bondable surface, but it does not remove the rust. It converts it. The orange becomes black. The metal underneath is never revealed. You have not restored the tool. You have painted the mask a different color. Neither category does what citric acid does. And what citric acid does is the reason every professional metal conservator, museum restorer, and antique tool specialist uses it instead of the products on the hardware store shelf. Here is the chemistry that the rust removal industry does not want you to understand. Citric acid is a triprotic organic acid with the chemical formula C6H8O7. It contains 3 carboxyl groups, each capable of donating a hydrogen ion. This molecular structure makes it a powerful chelating agent. The word chelation comes from the Greek word chele, meaning claw. A chelating agent is a molecule that wraps around a metal ion like a claw and locks it into a water-soluble complex. When citric acid contacts rust, it performs a 2-step process that no mineral acid can replicate. Step 1. The acid donates hydrogen ions to the iron oxide. The hydrogen reacts with the oxygen atoms in the rust, reducing the iron from its oxidized state back to a soluble ionic form. The bonds between iron and oxygen are broken. The rust structure disintegrates at the molecular level. Step 2. The citrate ion, the molecule left behind after the hydrogen is donated, wraps around the freed iron ion and forms a compound called ferric citrate. This is a stable, water-soluble complex that dissolves into the surrounding liquid and can be rinsed away with water. The iron that was trapped in the rust is now suspended harmlessly in solution. The surface where the rust was bonded is now exposed, clean, and chemically unaltered. The reason citric acid does not attack the underlying steel is thermodynamic selectivity. The iron atoms in solid steel are bound to each other in a crystalline metallic lattice. These iron-to-iron bonds are far stronger than the iron-to-oxygen bonds in rust. Citric acid does not have enough chemical energy to break metallic bonds. It can only break the weaker oxide bonds. It is selective by nature, not by design. The chemistry itself protects the metal. This is the difference between a chelating agent and a mineral acid. Hydrochloric acid attacks everything, good metal and rust alike. Citric acid attacks only the rust and physically cannot harm the steel. The precision is built into the molecule. If you have made it this far, you already know more about corrosion chemistry and chelation metallurgy than 99% of homeowners, most auto body technicians, and virtually every employee at every hardware store who has ever pointed you toward a $15 bottle of phosphoric acid when a $1 bag of citric acid would have done the job better, faster, and without damaging your metal. Subscribe and share this with someone who has a garage full of rusty tools they are about to throw away. Now stay with me because the money behind the rust removal industry is where the story turns dark. The global corrosion cost is estimated at $2.5 trillion annually, roughly 3.4% of global GDP. The rust prevention and removal products market generates over $30 billion per year. The average homeowner spends $50 to $200 per year on rust treatment products. Wire brushes, sandpaper, and chemical removers. Professional rust remediation for a single vehicle undercarriage costs $300 to $1,500. A 2-pound bag of food-grade citric acid powder costs $8 to $12 from any grocery store, canning supply section, or online retailer. 1 tablespoon per liter of water creates an effective rust removal bath. A 2-pound bag contains approximately 60 tablespoons, enough to make 60 liters of rust removal solution. 60 liters treats hundreds of tools, bolts, brackets, chains, and hardware items. The cost per treatment is approximately 15 to 20 cents. 15 cents to remove rust that a $15 bottle of commercial remover treats 1 or 2 items with before running out. You cannot patent citric acid. It was first isolated from lemon juice in 1784 by the Swedish chemist Carl Wilhelm Scheele, the same man who discovered oxygen, chlorine, and half a dozen other organic acids. It has been commercially manufactured since the 1890s. It is one of the most widely produced organic acids on Earth, with over 2 million tons manufactured annually. It is the active ingredient in sour candy, canning preservatives, bath bombs, and descaling products for coffee machines. It is everywhere. It is in your pantry right now. And it has never been marketed as a rust remover because a $1 bag of food-grade powder cannot sustain a $30 billion rust treatment industry. Now, here is exactly how to use it. And this method is the same protocol that professional museum conservators use on irreplaceable antique tools and historical artifacts where damaging the base metal is not an option. Step 1. Purchase citric acid powder. It is sold as citric acid in the canning section of grocery stores, as sour salt in some ethnic food sections, and in bulk online. Food-grade quality is all you need. Do not purchase industrial or technical grades for tool restoration. The food-grade product is purer and costs less. Step 2. Mix the solution. Dissolve 2 to 3 tablespoons of citric acid powder per liter of hot water. Use the hottest water from your tap. Heat accelerates the chelation reaction significantly. Stir until fully dissolved. The solution will be clear and colorless. Add a few drops of dish soap to the solution. The soap acts as a surfactant, breaking the surface tension of the liquid and allowing it to penetrate into pits and crevices where rust hides beneath the visible surface. Step 3. Submerge the rusted item completely in the solution. Use a plastic container, not metal. A citric acid solution in a metal container can create unpredictable galvanic reactions between dissimilar metals. Glass or plastic only. Step 4. Wait. For light surface rust, the visible orange discoloration will begin dissolving within minutes. You will see bubbles forming on the surface of the rust. Those bubbles are hydrogen gas being released as the acid reacts with the oxide. For moderate rust, allow 1 to 4 hours. For heavy rust with thick scale, allow 12 to 24 hours or replace with fresh solution halfway through. Step 5. Remove the item and scrub lightly with a nylon brush or a green scouring pad. The rust that has not fully dissolved will now be soft and loosened. A gentle scrub removes the remaining residue without scratching the underlying steel. Do not use steel wool. Steel wool leaves microscopic iron particles embedded in the surface that will cause flash rust within hours. Step 6. Rinse immediately with clean water. This step is critical. Citric acid continues to work after the rust is gone. If the item sits in the solution too long after the rust has been removed, the acid will begin to etch the bare steel, creating microscopic pits. The etching is cosmetic, not structural, but it dulls the surface. Remove and rinse promptly once the rust is gone. Step 7. Dry the item completely and immediately. Bare steel without its factory oxide coating is extremely susceptible to flash rust. Within minutes of exposure to humid air, a thin orange film can reappear on the clean surface. Dry with a cloth and then apply a thin film of oil, paste wax, or a rust-preventive coating immediately. This seals the fresh steel surface against moisture and oxygen, preventing reoxidation. Step 8. Dispose of the spent solution safely. Citric acid is biodegradable. The iron citrate complex formed during the reaction is non-toxic. The solution can be poured down a drain or onto soil without environmental concern. Compare that to the hazardous waste disposal requirements of hydrochloric or sulfuric acid products. I need to be completely honest with you about limitations. Citric acid removes rust. It does not remove metal. If the rust has penetrated deeply into the steel, consuming significant cross-sectional thickness, the tool will emerge from the bath with the rust gone, but with visible pitting where the rust ate into the metal before you treated it. Citric acid cannot replace metal that rust has already consumed. It can only remove the oxide that remains. For tools with moving parts, hinges, or adjustable mechanisms, the citric acid bath may dissolve rust from inside joints and threads, freeing parts that were frozen solid. This is one of the most valuable secondary benefits. A rusted shut pair of pliers soaked in citric acid overnight will often open freely the next morning because the rust bonding the joint has been chelated away. Citric acid will remove bluing, patina, and protective oxide coatings from metal surfaces. If you are restoring an antique tool or firearm where the original finish has value, test on an inconspicuous area first. Museum conservators use diluted concentrations and shorter soak times on patinated objects to minimize loss of historic surface character. And one detail that will prevent every tool you own from ever rusting again. After cleaning and oiling, store your tools in a sealed container with a silica gel packet or a piece of vapor phase corrosion inhibitor paper, which is sold at automotive and tool supply stores for under $5 for a year's supply. The inhibitor releases a molecular vapor that deposits an invisible anti-corrosion film on every metal surface in the enclosed space. Your entire toolbox, every wrench, every socket, every screwdriver, protected from rust indefinitely by a $5 packet that lasts 12 months. Carl Wilhelm Scheele isolated citric acid from lemon juice in a Swedish laboratory in 1784. The chelation properties of organic acids have been documented in metallurgical literature since the 19th century. Museum conservators have used citric acid baths on priceless artifacts for decades because it is the only common acid that removes rust without attacking the base metal. The chemistry is 240 years old. The application protocol is in every conservation textbook. The powder is in every grocery store in America. The only place it does not appear is in the rust removal aisle at the hardware store, where $15 bottles of hydrochloric acid that eat your steel and burn your skin are stacked floor to ceiling. And the $1 powder that a Swedish chemist proved 240 years ago removes rust without harming metal is nowhere to be found. A $30 billion rust treatment industry depends on you believing that rust removal requires aggressive chemicals, expensive products, and professional services. A $15 bottle of navel jelly depends on you never learning that it converts rust instead of removing it. And every rusty tool you have ever thrown away was a perfectly good tool wearing a chemical mask that costs 15 cents to dissolve. But now you know what rust actually is, and you know that the iron is still there. And you know that a powder found in lemons and sold for $1 per treatment wraps around the rust molecule like a claw and pulls it off the steel without leaving a scratch. That rusted wrench in the bottom of your toolbox could be bare metal by tonight. That corroded chain in the garage could look like it came off the shelf by tomorrow morning. And that pile of tools you were about to throw away could be restored for less than the cost of the garbage bag you were going to carry them out in. The metal was never gone. It was never destroyed. It was just wearing a disguise. And dissolving a disguise is not a $15 job. It is a 15-cent job that the entire industry priced at 100 times the actual cost because you did not know the chemistry. Now you do. If this vault changed how you see the rust on your tools, subscribe and share this video right now. Every share puts this knowledge in front of someone who is about to throw away a $40 wrench set because nobody told them the metal underneath was perfectly fine. Every subscription keeps this channel digging deeper into the vaults they thought were sealed forever.